Well, hello everyone. This is the second IBC meeting of the year. This is Greg Walker. I'm the research director here at CABA, and I just started the recording, so we're going to be sharing the recording for those that are unable to attend. I got several messages from people that were interested but couldn't make the call, so we'll be posting it on as usual on the IBC website along with the PowerPoint slides, and then the minutes after the meeting is completed. We'll be conducting those minutes. And next, I'll briefly go over the agenda of the meeting, and then I'll pass it off to our chair, Brian. And so right now, we're on the agenda, and then there'll be a quick call to order, a welcome, some introductions, a little bit about the IBC, a very brief administrative work with the approval of the past IBC meeting minutes. And then there'll be a white paper update from Ken Wax, who chairs the IBC white paper subcommittee, and give some updates on a couple of the white papers that we have on the go. And then there'll be our keynote presentation from Stephen from VoltServer, and on digital electricity and intelligent buildings. That'll be about a 30-minute presentation. Maybe it'll be 20 minutes of presentation, and then allow for 10, maybe even 20 minutes of Q&A from the audience. Then after that, we'll give a research update about some of the landmark research project that we're doing on it as part of the IBC for this year on AI and predictive maintenance, and the other research project on BACS in North America, really a market sizing project. And then a new business, James Carlini will be giving a presentation on the impacts of commercial buildings in post-COVID market and the shift that's taking place. And then following that, there'll be an adjournment. With that, I'll pass it off to Brian from Superior Essex to chair the meeting.
Hey, thank you, Greg. Thanks for getting us started for us. And hello, everybody. Appreciate you being here. So we will officially call this to order, and definitely appreciate your time and being here. You see in front of you, we got our chairs, myself from Superior Essex, and newly added here starting for this meeting. So I'm looking forward to it. We also have our vice chairs. We got Harsha, Robert, and Bob there, you can see. Harsha and Robert, extend their hellos to everybody, and regrets for unable to attend this meeting today, but we definitely have Bob with us today. So that's a leadership for the council here, the IBC. Definitely appreciate everybody's efforts. And for those that know CABA, I'm sure you know well, but if not, you're going to see some great information today. But also, CABA really focuses on the large building automation industry, and through research projects. Established back 2001. So a lot of great history in driving the research projects around the building automation industry for sure. And then as we look, to what we're going to be focusing on today around intelligent buildings, that sector is really grown and gaining a lot of traction. So CABA does a really good job in promoting that in the approach they do for all the research to focus on the optimizing the building spaces, the savings, energy efficiency, any of those things, trends. So a lot of great research has gone on over the years, and there's a lot in front of us too. So CABA is a great place for that. So if you haven't checked out their website, specifically to the IBC, make sure it's noted here, right? Make sure you check that out, CABA.org/IBC. So great things to check out. Let's take care of some business. I need to approve the minutes for the IBC minutes from February 17th. So I will entertain a motion to approve the minutes.
Hey, Brian, Bob, Allan, I motion to approve.
Thank you, Bob. All right. Do we have anyone who will second the motion? Could be anybody. We just need a second.
Chris Larry will second.
Nice. Couple seconds. I like it. We got a second. Are there any opposed to approving the minutes? Second. All right, hearing none opposed, the motion passes, and we have minutes from our last session. So we'll move forward with this session. So Bob, you want to introduce the keynote?
Absolutely. So it's with great honor that I get to do this today. Steve Eaves will present an overview of emerging electricity distribution technology called digital electricity, or DE. DE transmits electricity in discrete data-enabled packets, each verified for safe transmission on communication cable from a transmitter to a receiver. DE travels with data and installs with the same ease, safety, and speed as power over Ethernet, or PoE. But it also has 20 times the power and distance capability. Moreover, DE and PoE are often paired to serve a connected building. Steve will discuss the technology, show use cases, and discuss why this new format for electricity is timely for intelligent buildings. Steve has more than 20 years of experience founding and managing energy-related startup companies. Prior to VoltServer in 2006, Steve founded and served as CEO of Modular Energy Devices, a lithium-ion battery company acquired by Enersys in 2011. Modular Energy Devices became a leading supplier of lithium-ion batteries to the US telecommunications industry with thousands of installations worldwide. From 2000 to 2006, Steve founded and served as president of Eaves Devices that deployed power electronics. Ooh, somebody really has to mute, guys. They developed power and energy control systems for the B-2 bomber, ships and submarines, satellites, and the International Space Station. Steve has authored or co-authored numerous industry and academic peer-reviewed papers related to the energy industry. The papers have been appeared in respected academic journals and media outlets such as Newsweek and the Washington Post, and have been referenced by corporations, governments, and economic development organizations. Steve has more than 30 patents issued or pending related to energy storage and power conversion. And Steve graduated with a Bachelor's of Science degree in electrical engineering from the University of Connecticut in 1987 and is a US Air Force veteran. Steve, thank you for your prior service. That's great to hear. And I'm looking forward to what you have to say today.
Everybody, just checking to see if I can be heard.
You're very broken up.
Sorry, but our
Very poor quality.
building just got cleared up
Steve, can you hear us? Can you hear me? This is Bob.
for a long.
Steve, maybe you can, if there's a way you can call in with another line.
Hey, Brian, this is Dan Lowe. Can you hear me?
Okay. I think what I'll try to do, I'm gonna.
Yeah, we can hear you, Dan. You were loud and clear, bud.
Yeah, no, Steve's moving his card. You can't believe this, but literally 1 minute before this session started, for the first time in months, our fire alarm went off and I hear fire trucks coming. So Steve is in his car driving closer to get his Wi-Fi signal up. So
So what we could
Hopefully
pull
he
it,
can-
we
I
could
can
pull it
help out in the
audible and do some of the rest of the meeting and then come back
Yeah.
to this. I think that's
Let's do
probably the
that.
best strategy.
that would be perfect because these usually last about 10 minutes. So thank you for the suggestion. That would be awesome.
All right, it's a good idea. Did y'all get all that? See all that? That's good.
Yeah. You know, on my agenda, I had Ken ahead of me anyway with the white paper subcommittee.
That was true. I kind of misplaced that one.
That was meant to be. There you go, huh?
So I guess just Ken, you're on.
I am here. Just tell me when to
Go.
go. Okay. Thank you, Greg. Name is Ken Wax. I chair the White Paper Subcommittee for the Intelligent Buildings Council. We've been progressing a number of papers, and I will give you an update. First of all, the impacts of automated shading in building projects. We have done previous paper on this topic. It was a well-received paper, and this continues our investigation of window coverings using automation in buildings. Abhijit Panda from TRC Energy Services is the chair of the working group. We are looking for other volunteers. Current status is the working group meeting is scheduled for next week, July 26th. We expect the paper to be completed by the end of August. So that's our status on automated shading. The next paper is fire alarm systems in buildings. Suzanne Alfano from the Canadian Fire Alarm Association is the chair and submitted the proposal for this paper. The proposal was approved. We're currently looking for working group volunteers. This will likely be a joint white paper with NEMA, National Electrical Manufacturers Association. Suzanne was recently selected, has recently selected a co-author and will be scheduling a working group meeting soon. The paper is expected to be completed by the end of September. Next, architecting intelligent, self-learning, adaptive, smart campus framework for smart cities. Krishna Murthy Raman from Navtat Solutions is the chair. The proposal is approved. The last update was received in May. The paper is being worked on now. So we're glad to hear that's in progress. Next is needlepoint bipolar ionization and its contribution to smart and safe buildings. Rajiv Saya from Pure Air Control Services Incorporated is the chair. Paper is being authored by several members of Pure Air Control Services, Inc. We don't need additional working group members at this time. The experiment that went along with developing this paper is complete, and the paper is being written with expected completion by the end of August. So thank you to Pure Air Control Services. Next, we have part 2 of a series of papers that started last year on Wi-Fi technology. Like Wi-Fi, this is local communications within a building, but unlike Wi-Fi, this serves and is limited to one room because of line of sight with visible or an infrared light bulb. It's called the evolution of integrating Wi-Fi technology into smart lighting and control systems for the intelligent building. The chair and the author is J.B. Grove, professor at Wharton County Junior College. As I said, we already have a paper on this topic, so this is the second, and J.B. expects to do a 3-part series. The first paper was the introductory paper and was recently completed. The paper underway will be more technical in nature. We've received the draft, and I, as chair of the committee, and CABA has reviewed the draft and made constructive suggestions for improvements by JB. The paper should be complete by the end of August. All our white papers are available at caba.org/white papers. You're welcome to peruse the papers, and if you're so inspired, propose additional white papers. On the other hand, if you encounter papers that have been written outside of CABA that you think would be of interest to CABA members, please let us know. We have a separate committee called the CABA Information Council, which vets papers potentially of interest to CABA members in either the home or the building side. And we have a rigorous review process to make sure the paper has constructive information, either technical or marketing, and is not overtly commercial. We're not purists on that. Papers can mention commercial products, but we reject papers that say this commercial product is the only solution to the technical challenge. On the other hand, if it says here's the technical challenge, and by the way, here is a commercial product that addresses it, that's all right as long as it leaves the door open for competition. So that is the CABA Information Council. Check the CABA website. You can learn more about it. I'm the chair of that, so please contact me if you'd like info. So that covers our report on our development of white papers at IBC. Special thanks to the administrator, Marta Klopatowska, who has been extremely helpful in organizing the white papers committees at IBC. Also, she manages the white papers committee at the Connected Home Council and the CABA Information Council. So special thanks to Marta. She's been very helpful. Greg, that completes my report. Thank you.
Hi, everybody. Can you hear me now? This is Steve Eaves.
All right, perfect, Steve. Steve, this is Bob. I'm kind of moderating your section. I should probably start over and read the whole intro again, right?
I think we got that part. Yeah, that would kill me if you did that twice.
Perfect. Well, it's good to hear you clearly. So I will turn it over to you, and if we can hop in.
All right, great. Thanks for having me, everybody. I'm really excited to present to the group. I'm just learning about your group, and I've studied it in the background. It looks like you're investigating and participating in a lot of really interesting areas that cross with our business. So I'm happy to talk today. So I'm going to talk about a technology called digital electricity that we manufacture, but I was going to start on applications. And VoltServer is focusing on powering digitally connected infrastructure. And our sort of what we call heritage market space, although we've only been around 6 or 7 years now, is in communications, which, as I explain, I'll explain is a cross section with buildings right now. So I'm showing the Facebook supercell, which is this kind of huge double high cell tower that's designed to serve third world or emerging country communications. And it points out that the aspect of connectivity has become more to people than a convenience. It's become more like a utility. That I think many of you have heard this before. But related to buildings, particularly with the advent of things like 5G and private LTE, more and more services are going to be dependent on resilient infrastructure of communications that are inside of buildings. And those of you that are in the building industry will probably recognize that occupants are more demanding than requesting connectivity in these buildings. So next slide, please. Another area we're focused on is food. And what you're seeing here is an indoor vertical farm where, a lot of the work that we've done to date has been in investigating how big industry shifts are happening. What is the next emerging market that's on a global scale? And we also see this as one very interesting area that is tied to greater awareness of things like, pesticide use, local food production. But these facilities now in certain areas of the world, particularly in northern areas, are more advantageous than traditional farming methods like greenhouses. And we expect this to keep growing. These facilities are connected, advanced factories more than they are farms. So inside these facilities, our systems are running in there, but also sensors and HVAC and building controls and monitoring, all sorts of different process monitoring that's going on to make this a highly connected, advanced factory for food rather than what we traditionally knew as a farm. Next slide, please. And probably the newest area that VoltServer has got involved with is sort of transitioning from just core infrastructure for communications in buildings to sort of a progression into what we would call IoT applications, where rather than just powering indoor mobile radios and Wi-Fi. It also advances into low voltage DC powering, power over Ethernet devices, HVAC, direct DC HVAC, and interfaces with DC microgrids. Oh, could you drop back one slide? I think I'll spend a little more time on this one. I think Lewis South from Sinclair presented a little while back for the group. And so what I'm showing here is on the left is the Marriott Autograph Hotel that called the Sinclair Hotel in Fort Worth, which is a PoE connected building. And then on the right is a recent hotel that we were involved with called the Circa in Las Vegas. And they represent two sort of nice templates of DC buildings. So the left one, the Sinclair, uses power over Ethernet and finds connected devices that run on PoE technology. But the one on the right is using low voltage DC, primarily 24-volt systems inside the hotel rooms and the common areas for lighting and controls, building management controls. The connection here is that often when we talk about PoE, PoE is driving a secondary converter that then creates 24 volts or some lower voltage for lighting systems or devices. And so you probably hear interchangeability between low voltage DC buildings and PoE buildings. The place where VoltServer comes in and digital electricity is that we provide a backbone of data and power to the edge devices. For us, the edge device is the PoE switch itself. And so I'll show some use cases on that as we move along. Next page, please. So digital electricity is a new format for power distribution that breaks electrical energy into discrete components that we call packets, energy packets. The device to the left, called a transmitter, connects to conventional electricity, which could be a DC power source like a battery or a PV array, or an AC source, which would be a generator or a grid connection. And that power is converted to a high voltage DC bus inside the transmitter. And then the transmitter then breaks that DC power into a bunch of little packets. Each packet in itself is not dangerous, but when we put many of those packets together remotely at a device called a receiver, we recreate high voltage, high power energy at that receiver. And then the receiver could convert it to many different forms. We have versions that convert it back to AC, or low voltage DC for powering a PoE switch, or high voltage DC, which might be fed directly into, for example, a heat pump unit, or high power lighting like we do in agriculture. And those are the two core components in terms of hardware that is involved with digital electricity, the transmitter and the receiver. In terms of software, there's a number of different prioritization schemes that go to manage power in the building. And it gets very interesting when you have fine degrees of power management in these more advanced buildings, because you can greatly reduce the upstream power distribution system compared to a conventional building. We often start out with twice as many electrical rooms, and then it's reduced to about half that by the time the loads are managed. And what I mean by managed, in like a very simple case, if you're in a say an apartment that has a heat pump hot water heater and a heat pump or split system HVAC or VRF, those are loads that have a time constant on them that can be controlled. So if somebody's turning on a stove to boil water, you can get that water or that stove peak up to temperature while the hot water heater is delayed. And there's a number of other trade-offs that go into doing that, but it really relieves the power system all the way back to the head end of the building. I think I'll stop right there because we usually get a lot of questions at this point about digital electricity. Is there anything I can answer there?
Steve, I have a question for you right off the bat while others are formulating theirs. You had mentioned that transmitter can take in almost any type of energy from DC power to AC power, right off photovoltaics and so on. How does that impact the efficiency of renewable energy like PV?
If it's a direct PV input, we usually operate end to end in the 90s, north of 90% efficiency when all the stuff is factored in.
And how does that compare to traditional, like if I had it on my house and it was coming in and being converted to AC for, traditional power infrastructure?
It would be nominally less if it was your house in terms of overall efficiency, but nominally more if you're in a large venue, because our transmission efficiency across longer distance is much better than what you might get in 220-volt power, for example. Our native distribution buses is 336 volts DC. The receivers are extremely efficient. I mean, if it's direct DC transfer, like say you were, and I'll have to back up a little bit. Remember, you have to have a conversion somewhere. So solar converts through an inverter. It could be a grid-tied inverter to your house. But if you have batteries that you're doing sort of self-consumption, you have multiple conversions, and those occur in any system. We sometimes move the conversion locally, like I was talking about the apartment application. The DC to AC conversion would occur right in the hotel room or right in the apartment building, but it has to occur somewhere. So we're not necessarily adding conversion losses.
But at the end of the day, it's more efficient than what we're accustomed to seeing when we're looking at renewables.
Yeah, I'm always careful to say that. I mean, we're nominally more efficient. I mean, we're a couple percentage points better than what you'd be able to achieve. And in the lighting in the ag system I showed, we're greatly more efficient. Would be a whole explanation there. But the big reduction is in distribution infrastructure. It's sort of what's called a converged system that I'll talk about, that reduces the amount, the disparate systems that are in a common building right now. That's IT and utilities and the operating part of the building versus the information technology part.
That's great. I appreciate you diving in there. I see James Carlini, you have a question?
Yes, I just wonder on the transmission media, what's the actual wires when you talk about wires? Is it copper? You can't do it on fiber optics, can you?
No, we transmit on common communication cabling.
Like Cat5?
Well, Cat5 is a little thin for us. Usually it's an 18, 16, or 14 most commonly. 18 gauge to 14 gauge communication cable that you would know is in a building is like, sometimes it's called CMP or CMR rated cable. Okay. The important thing is that space between the transmitter and the receiver is it's rated as a class 2 circuit in North America. So it runs in communication ducts. So it's the same space that you're running your Ethernet cables in. And this technology, even when it's transferring many kilowatts of power, installs with the same practices as Ethernet cable.
And it doesn't cause any EMI or anything like that?
The EMI is very carefully considered in the design of our systems. Most of our traditional customers are large communication carriers like Verizon or T-Mobile or the big carriers that are out there, and our systems travel in the same space as their communications. So it's been highly vetted in terms of a technology for EMI to not interfere with all that stuff.
Okay.
And just for everyone else on the line, there's two ways that you can ask questions. There's a Q&A box down the bottom. If you type that in, I'll be monitoring that. And also on your controls at the bottom of your screen, there's a raise hand function. If you click on that, I will also know to bring you on and you can ask your question verbally.
I have a question if you see my hand, David.
I can. I was just looking for it. Go ahead, David.
Yeah, okay. Just to build on what James asked, I'm looking at that refrigerator and I'm asking you, you made a comment that when that compressor has to come on, that it will get the necessary energy. I'm a system planner from electricity, so I see some merit. but every time you convert something, there are losses. So maybe you could just explain how this meets the loads of the AC that ends up to be in the room.
So is the question on the conversion losses in the system, or kind of how we meet the load demand? Is that?
Well, you mentioned that, you could tell the hot water heater to go off, but the loads at the end of this wire have to be met with, in some cases, AC. And so you're converting twice, even though you're getting benefit of sending it over the cable that's not copper. I just wonder how the efficiencies are.
Yes, so it depends a lot on the type of building. Things like lighting loads can be met, as you know, with DC conversion. And, as I was pointing out, things like agricultural and building lighting and things like that, we have very efficient conversion without ever going to AC.
I agree.
Yeah, and as you pointed out, there's always some AC loads in the system, and we won't always be more efficient depending on the building type. But when you have a renewable based system, like a DC microgrid based system where you have solar somewhere and you're doing self-consumption, then we can be more efficient because we haven't added any conversion in those instances.
Just seeing the agriculture and the high efficiency lamps that have to be driven to make that grow. So anyway, okay, thank you.
Yeah, those are as you know, those are very large. That facility I was pointing out is about 1 megawatt. And that's even a smaller one. They range from 1 to 7 megawatts in terms of installation power.
Great. Thanks for the questions, David, and of course, Steve, for the answer. A question that came in through the Q&A box. How are things with AHJs? Are you having any approval problems? Are there things that need to be discussed up front? Tell us about that process.
Early on, we had a lot of education we were doing in terms of our code path. Like we install under Article 725 of the National Electric Code, and our approval standard, our listing standard is 62368-1, which is a very common power supply standard that's actually in Article 725. So we're a listed product in particularly mentioned in 725, our listing standard. But it is, we do educate a lot in new customers because it is a very strange technology. It's completely new. But as far as having problems, over 7 years, I can count maybe on one hand the times where we really had a delay in a project because we were educating AHJs. Remember, we actually spent a lot of time presenting to inspectors organizations and electrician organizations and things like that to try to lighten that up. There is a new code development standard going through now called Article 726, which we're in the middle of, which will kind of create a whole new code section for this type of technology. But that will be a couple of years before that comes out.
Great, thank you. And just a pause. Hey, Greg, how are we doing for time? We started a little off, so I don't know where we are.
We started about 22 after, so we probably have we have some time left for sure.
Okay, great. We got one more question, and Steve, if you're going to address this later in the presentation, that's fine. We can defer it for now. But the question is, what is the data transmission capacity millibytes per second? What is the edge controller and format for signal for smart devices?
There's different bands of communication in the technology. We often run in parallel with fiber, either in the same duct or same cable for high-speed stuff. And then the embedded data is low speed. That's more for high resiliency control and metering applications. So if we're doing a video camera, we drag a fiber or copper Ethernet along with us. And if it's just a very simple application, we don't need that.
Excellent. Great. Well, that's all we have right now. So if you want to continue on, we'll just kind of address questions as they come in.
Okay, let's go to the next one, please. This is just gives you some idea of where we sit in the safety spectrum. The reason, I mean, it all comes down to speed and cost, right? And conventional electricity, as many of you are probably keenly aware, is very expensive to install, but all of that stems from its inherent safety characteristics. So this technology was designed from the ground up to be inherently safe. So we send a packet, and then we make sure that the lines are clear and that there's no faults 500 times a second before any more energy is sent on that line. If there is something going on, then we don't send another packet. And that takes the place of overlay devices that are in conventional electricity, like I'm pointing out GFI, RCD, arc fault, circuit breakers, and things like that. When we go through that process of sending individual metered packets that are very small in energy content, it inherently covers all those faults. So, but very importantly, it covers two faults that aren't covered in the world today, which is a resistive fault, and that's sometimes called a glowing fault, where somebody on a say an AC receptacle doesn't tighten the screw down well, it turns into a heater and melts the receptacle down. It's actually the most common cause of fires in North America, and it's not covered by these other devices. It's not picked up, it's not really high current, so it's not picked up by a circuit breaker, it's not a ground fault, it's not an arc, it's just a heater that appears in the middle of your wall and starts fires. Digital electricity has the ability to sense that type of fault, as well as human touch faults, where today, if you touch a ground fault interrupter can protect a human if you bypass the common in a 3-wire connection and come through a ground surface. But if you touch the black and the white, the hot wires, the 2 hot wires that are in a 3-wire circuit, it doesn't know the difference between you and a vacuum cleaner or something else drawing the load. So digital electricity is very unique in that it can separate a human touch element from the regular load that's on those wires. Next page, please. This is convergence that I talked about, and this is about by having the ability to run high power and data at significant bandwidth in the same channels, it helps reduce the building complexity by bringing in all these sort of diverse applications into a common backbone. That I'm sure many of you have heard the subject of digital convergence before, but the concept is that in the future, many of these devices will be IP based on a common IP platform, and the digital electricities comes into this world by being the powering platform for digitally connected devices that's allowed to live in the same channels as the data. And so it allows you to have a common, for example, a tray architecture that's very common in Europe. You'll see all sorts of devices running in a tray, lights and sensors and things like that. And many of some more interesting applications that we're involved with will power a whole, say, high-end office, Class A office space from a tray platform that has the lights and the sensors and powering desks and everything else from that common platform. Next page, please. So this is where we're seeing the most value for our customers. It's in places where the customer values control and analytics. I'm always touting this thing that JLL came out with, which is called 330-300, where the utilities in a facility are about $3 a square foot. The space itself and real estate is about 30, but people are $300 a square foot in a metro area. And that, where analytics and control, I believe, have some of the most powerful benefits are when it brings all those things together. So where you're actually presenting a workspace that is pleasant and productive for the people that are in it, and you actually have control and the analytics to make sure that space stays that way. So that's a customer area that's very important to us. Resilience is another area where we talked about 5G and new technologies that are coming out there. As applications build up around these new technologies, they're counting on resilience. So, 5G in a building will have the bandwidth that will exceed Wi-Fi, but also it will have the reliability of a connection that is similar to a wired connection. So it brings up new things like machine controls and things that nobody would ever imagine doing wirelessly. But you can't have that and not back up the power too. So where customers value the ability for resilience, that's another important area. The Circa Hotel that I pointed out a little bit earlier, their application involved what we called a resilient overlay, where we placed a backbone of digital electricity and low voltage powering that covered all the things that basically made the customer or the occupant comfortable enough during an outage. It maintains building management, so you're not cycling building controls and controllers that take reset times and they come up wrong when they do come up. It just keeps everything sort of solid so that the folks are not uncomfortable and that they can evacuate if they need to, which is very important these days in Las Vegas due to past events. And if you look out at like what's going on in Texas right now, there's a new emphasis or new focus on resilience in buildings. Larger venues, as I explained, we have a transmitter and a receiver unit. That's expensive if the distances are short on the run, but when distances get to hundreds of feet, that expense is amortized through the elimination of very expensive conventional distribution systems. So we make it, the space in between is much less expensive to install using digital electricity. And
hey,
then,
Steve, a question that kind of ties into what you're talking about is how compatible is the receiver to accommodating various DC voltage levels? Can it accommodate various voltages at the load, or does it need to be tuned to specific product voltages?
The receivers are usually set to what the customer needs out there. Like a 57 volt. 57 is a very common one that serves both our traditional telecom customers, but also PoE, right? We make a 24 volt version that is very common for like building controls or lighting, LED lighting. And then we make high voltage converters that are very efficient. They're super efficient because we're not down converting or converting to AC. And that feeds directly into things like where I pointed out the high power agricultural lights and things like that. So we have a number of them as well as AC that meet the needs.
Great. So we have about say 5 to 6 more minutes left in our window. Right now we're kind of good on the questions. So just to give you a heads up of where we are time-wise.
Okay, great. So here's a stadium application, and the main thing here is that the transmitters, these range anywhere between 100 kilowatts and 2 megawatts, these installations. We have these rooms that have digital electricity transmitters in them in a central location, and then it can travel as far as 2 kilometers from those transmitter locations. And you can see the advantage is it's using the cable tray that's underneath the seat. So that cable tray is carrying our power as well as data lines. And that's another sort of example of convergence. Very rapid to install and low cost versus hard conduit runs through a building. Next slide, please. This is the indoor ag facility. You can see it's the cabinet sitting in an electrical room. Same deal, except these ones, we don't do any conversion. The DE goes right into custom designed lights that are designed for digital electricity that direct drive. So we have no conversion at the remote end. Next slide, please. I took a little more time on this one, and this is a building application. Just generally what you're seeing is all the stuff that goes into getting power up to a desk in a high rise. You have a service transformer or a control center in the basement. It goes up through riser distribution and then through a local transformer. And then if you have controls, which you often do, particularly in California, say, you have relay panels and breakers, and And then you finally get to the desk and you have a bunch of adapters that finally convert what is going to be DC in the end back to DC from AC. And if you go to the next slide, please. This one shows kind of the simplification that you have with the DE system, right? Your data and your power are traveling on communication cabling. Because of the distance capability, you don't need local conversion or local transformers and breakers and things like that. It all runs up through the riser into the desk. And at the desk, it's a direct DC conversion, not back to AC. And in these DC desktops, we convert down to about 20.5 volts, which is compatible with USB-C, where a lot of devices now are designed to charge and run on USB-C. We can convert to AC, and as one of the participants mentioned, we take losses when we do that, so we prefer to have a full DC system. Another thing to point out very carefully is that all these are resilient, right? When you're in this central distribution system, without a lot of extra work, you can bring in generator feeds. It's sort of the concept of a distributed UPS, where you get the benefits of centralized batteries and controls and controlled and accessible space versus local small UPSs that fail a lot. Next slide, please. And this is very similar to the desk, but I'm just pointing out here how PoE is done. Again, this is the transmitter rack in the basement that is being pointed out at the bottom of the page is the actual transmitter rack from that building, from the Sinclair Marriott. And that one rack is powering, there's still AC in the building, but a ton of it is being powered by PoE, and it's all powered from that rack. I think that rack is about 120 kilowatts. And then it goes up to receivers that convert to 57, and then to PoE switches that run on that DC. And I think that's all I have for today. I'll take any questions.
Great. Well, that was awesome. I appreciate you taking the time with us today. I know I certainly learned a lot. We don't have any new questions in right now. And I thought that was a really thorough overview, right down to how the strategies are deployed and the benefits to the end user.
Great. Thank you very much. It was my pleasure to present to you guys today.
Awesome. So Greg, I think with that, oh, I did get one. Are there any size limits? I'm not quite sure how to qualify that question, but I guess let me try to rephrase that. Is there, say by square footage, what's the smallest to the largest that makes sense for a DE infrastructure?
I think you could look at it where the run lengths are in hundreds of feet. You know, it's not in a single office where it's 20 or 30 or even 100 feet. You know, I would start at like 200 or 300 feet up, and which puts us in the larger venue space, but that's where we make the most sense.
Is 100,000 square feet a good demarcation as far as being over that size?
Yeah,
can we get into smaller buildings than that?
Yeah, that's a good spot. That would be about where we operate in.
Okay. Excellent. Good to know. And thanks for the question, Dan. That was something that was definitely worth chatting about. So with that, Steve, thank you so much for taking the time with us. Greg, over to you. What's our next agenda topic? The research update with me again?
Yeah.
This is the Bob meeting today.
If you want, I could take it over as well. It's
no, that's fine.
That's what we like, Bob. Good job.
Well, we had two people. We had two that were that couldn't make it. So I think you're doing some of the heavy lifting this time.
Great. All right. Well, I'm sure I'll be bringing you in for part of this as well. But first off, let's talk about the AI and predictive maintenance in intelligent buildings. Great research topic. I'd like to thank all of the funders for this, the sponsors. You can see the logos there on the slide. And for anyone who's not aware, CABA has opportunities to have various levels of funding or sponsorship for these landmark research papers. And if nothing else, to have your name and your logo on these really notes you, helps you stand out as a market leader. Some of the funding packages will allow you various levels of input and approval on the direction of the papers as well. This research topic was selected by the CABA Board of Directors back in February. And an RFP went out to the CABA member research firms. We received 4 bids on it, which is great. So it's always nice to have those options. They were narrowed down to the top 2, and then the initial funders made the final selection of Harbor Research. The purpose of this research is to examine various aspects of predictive maintenance and artificial intelligence in the intelligent building industry. This research will also develop recommendations for stakeholders on how they can best position themselves in this evolving intelligent building landscape. This new research will address the many challenges and opportunities that exist around artificial intelligence. It will utilize both qualitative or in-depth interviews and quantitative, which is consumer industry questionnaires, methods to prove actionable data relevant to the state of the market, key industry players, business opportunities, technical barriers and opportunities, future market directions, issues, use cases, and industry recommendations. CABA and the IBC are actively seeking funders for this research. There are 18 funders on the project so far. Again, thank you to those funders. This project itself is costing over $130,000. So the various levels of funding, there's a $5,000 funding rate, a $10,000, and a $15,000. For $5,000, you can pre-buy and get the full research paper as well as the final webinar. Greg, I just want to point out, I think that typically during that moratorium period or after the moratorium, to purchase the research paper is somewhere around 5,000, isn't it?
Yeah, it's 4,900 for CABA members. So it's we design these projects that for all essential purposes, they're fully funded by the funders themselves, and we may get 1 or 2 sales after the fact by people who find out about the project late.
Yeah, so bottom line is, if you see value in this research paper and you intend to purchase it anyway, you might as well spend the extra $100 and have your name on it. The next level is $10,000 sponsorship. That tends to be the most popular. Also, with that, you also get to be on the steering committee and get a special webinar specifically for your organization. This level can also participate in the think tank webinar, which is hosted by the research firm once the research is complete. And the highest level of funding is $15,000, and all the benefits of course, the lower levels and your organization would also get a case study incorporated into the research, which will be shared within the executive summary. So if you are interested in becoming a funder, please make sure you reach out to Greg Walker at CABA.org. He can also be reached for any additional questions and so on. Anything else you want to add to that, Greg, before we move on?
Just that the second steering committee is taking place on the 27th of July, so that's a Tuesday, and the full methodology and the research questionnaire and it was going to be finalized by the end of July, and then we'll be starting the data collection stage. And the project is expected to be completed in Q4 this year, like maybe late November, early December timeframe for the final webinar presentation.
Great, awesome, thank you. That's all I have for this agenda item. I think I'm going to turn over to you for the next one, right?
Yeah, thanks a lot, Bob. So this is I'll be fairly brief. This is the other collaborative research project that the IBC is undertaking this year. This is actually a different research type of project in that it's an annual research project. We're going to be completing with BISRIA, and they are a lot of experience in these market sizing research in various spaces in the intelligent building world. And this is going to be looking at BACs and market sizing in North America specifically. It was originally brought forward by Raphael Imhoff from Siemon, who's our CABA board member. And it really spawned from the need of that there was no really reliable sources of market sizing data in the building automation control system space, particularly in North America. So what we did is we reached out to the top 9 organizations as an invitation only group, and 8 of them decided to join the project, and they're contributing their market data, and we're agglomerating it all and anonymizing it and then sharing it out with the group, so each one of those companies and control companies would have a greater clarity in terms of their market sizing. And the idea is to continue this on year after year and have quarterly reports and updates on a regular basis. So I guess it's a different type of project than this invitation only, but it's just an information that this is the other work that we're doing here at the IBC, and there are other sort of collaborative projects that we're undertaking. Does anyone have any questions about this one, or maybe even the artificial intelligence predictive maintenance study?
Greg, this is David. Is this going to be done by BISRI? Because we see their annual presentation, but they used to just cover Europe. Is that why?
Yeah, this is it's going to be done by BISRIA. It was done by a recommendation from Raphael, and we vetted them, and I think they're actually on the call now, and they have a lot of experience doing these market sizing projects in this particular area. So it's going to be done by them, and it's going to focus more on North America. So you're right. They're based in the UK, and they have a lot of presence in Europe and even Asia, and doing market sizing projects. But they're also do North America as well. They're more of a global market sizing specialty.
And the C in BACS, what is the C for? Building automation and control systems?
Yeah, building automation control systems.
Okay.
Yeah, sorry.
Okay, because there's confusion as to AI and FD. Okay.
Yeah, I spelled the whole thing out. It got a little long, so people said
Yeah.
just do backs. So yeah.
Awesome. Thanks, Greg. There's some great research updates there.
So I guess I'll pass it off to maybe Brian, the chair, or maybe James.
Yeah, no, I'm here. Yeah, James, if you're ready, I think you can present on the paradigm shift for commercial buildings and post-pandemic market. You ready to go?
Yes, I am. Thank you.
Awesome.
And thank you
sir.
for inviting me to speak. And I think there's some big things going on since the pandemic has happened. And I want to discuss a paradigm shift that I started to see last year. I wrote a couple articles about it, and it's actually becoming more empirical as far as the information and not just anecdotal. Next slide. New market, I'd say 18 years ago, I was interviewed on Business 2.0, and I talked about the shift in what was going on. The article was Escape from Silicon Valley. And I said that if people are going to move from Silicon Valley, they're going to be looking for not just location, but they're going to be looking for location connectivity. Since then, those 4 areas that you see up there, real estate, economic development, infrastructure, and technology, those were 4 independent areas. And within the last, almost 2 decades, they have converged and they're now tied together. And that's the new market for smart cities. You have to sell into that type of market because all those have converged, and they've impacted regional economic development. And this is very big in every city that's looking for trying to create jobs and create a larger tax base. Next. Well, if we look at work from home, the workforce that is becoming a growing workforce in itself, one company, this is empirical result. This is empirical information as far as pre-COVID. It was 6% of the people that were interviewed of this company. There's 1,000 people within the sampling universe. 6% said they'd like to work from home 5 days a week. That was pre-COVID. And now if you go further, next slide, in a post-COVID, they surveyed these same people again, and that's jumped from 6% after working at home for a little bit over a year. That's gone from 6% to 46%. That's a real huge increase. And I think that's going to impact commercial real estate, because you're going to see more people working from home and not coming into commercial office space. Next. And that, I think, is just the tip of the iceberg. When we look at mission critical applications, and I worked in mission critical design for the last 30 years, what we look at with mission critical application means there can't be any single point of failure. And in working with buildings like stock exchanges, airports, 911 centers, we need to look at diverse power coming in from several sources and diverse routing for broadband connectivity from at least two central offices. And that's very critical when we talk about building resilience. Next slide. Just a little bit of background. You cannot have a smart city. Go ahead. You can jump that. You cannot have a smart city if you have dumb buildings. Next slide, or next, just there you go. This is something I talked about 1 or 2 years ago when everybody was coming out with smart city buzzwords and buzz phrases. Everybody talks about adding so much to a building, but if you only have a single point of failure, either with power coming in from one substation or a single point of failure for all the network connectivity coming into the building, you really don't have a smart building and you can't really have a smart city. Next. The big question becomes, who will lose occupancy? Those who fail to see the paradigm shift that is happening right now, and those who do not have intelligent amenities in their buildings. Next. And that includes redundant power coming in from at least two different substations, redundant network connectivity, at least coming in from 2 different central offices, and preferably more than one network carrier. And 3 is routing diversity. And you can see that in some areas, just recently, the Atlanta airport about 2 years ago failed because they had power coming in from 2 sources, but they didn't have routing diversity, and that shut down the whole airport. And then it shut down the whole nation as far as air traffic. So these are becoming much more important issues to make sure that it's incorporated in building designs, not just for specialized buildings like 911 centers or stock exchanges, but in every corporation today, 1 out of 3 applications are considered mission critical. And that definition, mission critical, means you cannot have a single point of failure. So if you want to attract corporate tenants, you must have redundancy and resiliency in the office building that you're trying to promote or trying to lease up. And in the case of most office buildings across every metropolitan area, most of them are not designed that way. Next. So the question becomes, in a post-pandemic economy, can the city compete? And from an individual property owner or property management company, can your buildings compete? And this is going to be more important because think of musical chairs, but think about it from a reverse standpoint, where now you have more buildings than you'll have tenants and occupants, because they're going to shift some people to work from home permanently. So the question becomes, does your building have all these extra amenities that can support mission critical applications? If not, your building is technologically obsolete. And that's going to become more important as time goes on. Next. The question is, how many buildings in your downtown areas are technologically obsolete? That's the proposed research study that we want to propose to the members of CABA, because I think it's very important, especially if we're adding in all these other amenities like we talked about earlier in this meeting, like digital electricity. If you have all these things running within the building, the question is, what's coming to the building? And is that a single point of failure? Next. Where are the opportunities to add these amenities? And this is an issue that every major metropolitan area, and including suburban office parks, needs to review. Next. So what we're proposing is we're looking at buildings. The test methodology would look at power, we'd look at broadband connectivity, we'd look at spare capacity of cabling within the building using a twins formula that I wrote up in my book, Location Connectivity. And that's where you look at twins, total pair, working pair, in-service pair, non-working pair, and spare pair. And believe me, most people that manage buildings do not have a clue in what's running in their building. And most of them realize that they have a single connection to one central office and a single connection to one power substation. And that really has to be modified if they're going to look for tenants in the future, because more and more companies are looking for mission critical support, mission critical applications. They're looking for support from the building. And if the building doesn't have diverse routing to 2 separate central offices and 2 separate substations for power, you really can't say it's resilient enough to support mission critical applications. And next, I'll answer questions or comments. My contact information is here. If you'd like to talk to me, I would like to talk to you. If you'd like to help sponsor this type of review. And I've worked in this type of research for several decades. In fact, I was the first one that came up with measuring a building's IQ back in 1986. We looked at all the buildings in Seattle for JMB Realty and JMB Property Management Company, which owned several buildings on the West Coast. And what they were doing was looking at adding $20 million into one building to see if they would become more technologically advanced than the other buildings that were surrounding the downtown area of Seattle. So I've worked in this area, pioneered some of these issues, and we're looking for something to review buildings again, because now it's become very important that buildings have all this routing diversity and multiple connections to several different power areas and several different central offices in order to become the resilient building that most tenants will be looking for.
Great, thanks, James. Any questions out there?
I have, James, this is David from BIQ. Would the insurance companies see this as a way of funding? I mean, what is the penalty? Obviously, we learned from the Texas, fiasco. And also the question I have is about net zero buildings, where the buildings are going to be their own generator. How does that fit your mind?
Well, everybody, I think insurance companies are a whole different facet of this. And I think you have a point that if you have a building that has less than redundant power coming in and less than redundant connectivity to 2 central offices, that might make a big difference as far as what's their insurance rate, or really what's the marketability. I think it really falls down first into what's the marketability of a building if it fails to show that it's resilient.
So instead of insurance, it'll be better leasing, better rates from those that are told this building is resilient.
Right, because I've seen several companies already have talked about the reduction of their corporate leasing footprint. In other words, if I have 40,000 square feet and now I'm looking at taking 30–40% of my people and having them continue to work out of their house instead of coming back to the office, I don't need 40,000 square feet anymore. Maybe I can do with 10,000 square feet. And this is happening in different areas. This was a Chicago Tribune article back in March of this year where in Chicago, they say they have the equivalent of 5 Sears towers, now called the Willis Tower, but 5 Sears towers worth of vacant space in downtown Chicago. That's huge. And it's like the reverse. The best way to think of this is like the reverse of musical chairs. You have corporate leasing where companies are going to be looking for less space because they have to acquire space for less people, because the people that are working from home are not going to come back. And I see more and more companies looking at that, because the other thing that I failed to mention, but I'll mention this now, is that the productivity rate of people working from their house has gone up anywhere from 20 to 26% on average. So think about that. And these are our measurements that this international company did on their own workforce, that they're seeing productivity rates of 20 to 26%. That's like adding a person to work all day Saturday for free, and they don't have to pay for any of the office space. They don't have to pay for any of the desk or computer equipment or anything like that. In fact, one company said to all their people, come in and pick up your office chair, pick up your computer monitor, because we're not going to really keep all the space. And so what they did was they had their own employees come and clear out some of the office, and you didn't have to hire a third-party company to take some of the furniture out, because people took it home and they looked at it sort of as a bonus, like, hey, I'm getting a free computer monitor, I'm getting a free ergonomic office chair. But that's because of people are going to be working at home. And not everybody, I know there's arguments that say, oh, well, not everybody can work at home. Granted, not everybody can work at home, but just think if you impact a city of any size where you look at 30% of the people not returning to work, 20%, 30%, it may not get to be 46%, like in the case of this company, but let's just say 30%. That's going to impact on how many companies need how much commercial office space within these buildings. And it's like, the best way to think of it is reverse musical chairs, where instead of taking a chair away, I'm adding 5 or 6 more chairs, and 3 of those chairs have only 3 legs and are broken, because, as I said before, unless your building has all these redundant capabilities coming into it, corporate site selection committees are not going to take a look at that building seriously. They're going to say, hey, we need to have better redundant capabilities coming into this building. You don't have it, we're on to the next building. I've already seen that in suburban office parks, where if you don't have the regular office park with multiple carriers coming in and multiple electric feeds coming in, you're not going to attract corporate R&D facilities or anyone that's dependent on connectivity. Any other questions?
I see Steve. Steve Eaves, you got your hand raised?
Yeah, I just wanted to add a little bit related to the microgrid comment on buildings that have their own energy sources. We did experience in that the Marriott application in Fort Worth, that because that building had a redundant grid feed, the owner did not need to have 8 hours of fire pump backup. So they actually were able to implement a lithium-ion battery storage system in there, which wouldn't have been practical because of the high power levels of, pumping for 8 hours. So it was actually a big advantage that they had that redundant feed, and it paid off in terms of the overall building design.
So Steve, I have a question in light of the presentation I saw recently by James Dice, that the question about PoE is that if everything is connected to that one cable and it fails, all those things aren't powered anymore. Like, how do we fit this into the existing building and give redundancy?
Do you mean, I mean the PoE infrastructure
infrastructure is highly redundant. There's redundant feeds to all that stuff. The centralized battery, of course, is another discussion, but that's also modular.
Right.
So those systems have modular channels on them.
Thank you.
Mm-hmm.
Right. Thanks, Steve. There's a couple in the chat here. We got a few minutes. What is the best way for the tenant to know the mission critical resiliency level of the building?
Well, that's something, if I can answer that, that's something that should be asked, but I would say that most property owners and property management companies don't know the answer to, because in reviewing this type of thing in the past, most people did not know what was actually running in the building, as far as, do you have 2,000, 3,000, 4,000 pair coming into your building, and how much of that out of that total pair are working pair, how much are in service, how much aren't working, and then how much are spare pair. That to me is not a really hard number to get to, but yet I would say 99% of the people that are running buildings don't even have that information.
Good point.
And this is something that, after working with places like the Chicago 911 Center, planning and design, the Chicago 911, where everything in there is fiber optics, and we connect fiber optic to 80 police and fire buildings across the city with 176 miles of fiber. This was done like 25 years ago, long before most people even talked about fiber optics. I was the mayor's consultant on that, and I said, why do anything with copper when you're going to be looking at fiber optics down the road as the best way to transmit information on a high-speed basis? Why not put in fiber right now? And we had big arguments with the phone company at the time. They said, hey, you could just have this new building open up with copper in it, everything would be fine. And I said, you're going to obsolete this building before it's even open. That was back in '95. And most people that have gone through that facility have said, wow, this is still state of the art. So it's something where when people look at redundancy, if you look at special use buildings like a 911 center, or like the Chicago Mercantile Exchange and other stock exchanges, something like that, you see a tendency to design that up front. But what I'm saying now, most office buildings that want to get a Class A corporate tenant better have redundancy and reliability and resiliency all built in, not only within the building, but also coming to the building. Otherwise, they're going to move on to some other building or even some other state. And I worked with a couple of different large office parks. We did a 800-acre office park about 10 years ago, and we were running multiple carriers coming into that at 40 gigabits per second. Now that's 10 years ago. That's very high speed at the time. And there's a lot of people today that, think that a gigabit is fast. Well, if you're going to build any type of special business district, like a TIF district in different cities, you really should make sure that the infrastructure supports the latest power and what I call intelligent amenities, power and broadband connectivity, because otherwise the corporate site selection committees are just going to pass you up. This is something that broadband connectivity wasn't even on their top 10. There wasn't even on their list at all a decade or so ago. But today, broadband connectivity on a corporate site selection committee's list is probably one of the top 3 issues that they look at.
Very well, very well. Well, I'm going to close this part out. So we got the last 5 minutes to close out the meeting itself. But please reach out to James. He has contact information there. But definitely reach out to him and ask any questions, and definitely get involved.
Thank you very much for having me present. Thank you, and thank everybody for listening. I hope you got something out of it.
Yeah, very relevant right now, right? There's a lot of it going on. All right. Any other new IBC business? Any ideas for new business, new white paper ideas, new research, new projects, new agenda items for the next time? Kind of open it up here for the next couple minutes. Just anything out there that we should all be looking at.
This is David Katz again. Good thing I had a backup computer to Zoom failed on one. I just want to bring to the attention, last meeting I spoke about the smart air filter that's Wi-Fi connected. It's going to be connected now to the BAS, and a new indoor air quality sensor that's being developed here by a Canadian firm that has PM capabilities well below or well smaller than current sensors, and I'm trying to get them to join. So I'll hopefully get these two together, and they might be interested in the research on preventative maintenance.
That's a good one. You know, you do see a lot more apps going right under the intelligence, you know, smart PoE, any of that, right? So there's a lot of applications that are just coming left and right. So being aware of those is definitely a key. Anything else? You don't have to raise your hand. Oh, you could if you want. I could call on you or just speak up. So anything else you want to see? Got a quiet group today.
Again, this is David. We have our new building intelligence quotient previously developed for CABA, but now we're doing it with the Chinese Academy of Building Research. And we're looking for pilot buildings to try it out. It's not yet on our website, but we have a spreadsheet model that we're looking for people who want to try a pilot to get in contact with me at dcatsbuilding-iq.
Very nice. Thanks, David. Anything else before we move to close out? All right, hearing none. I mean, you have our contact information too. So if you think of anything comes up you see as you're out and about in the industry, you know, make sure to get it to any of us on the IBC or to Greg, you know, directly at CABA, you know, and make sure you know, speak up so we can get some good things going. You know, really appreciate, you know, Steve being on today and James, and then, you know, Bob for your updates and everybody. So really appreciate all that. A lot of great things going on right now. It's our goal to, you know, give you all and to the masses and abroad, you know, the information and what's going on. So that's only going to continue to grow and expand for sure. So definitely appreciate that insight. And make sure you reach out to them, right? If you have any questions, further comments, want to learn more about it, they are great resources. So you make sure you do that. All right, looking ahead to the next one's hard to believe. You know, here we are finishing up July, but you know, as we get into late September, early October, we'll schedule another IBC meeting, so you can all come and check it out. So look for that to come out. I'd say, you know, September, October timeframe, and then we'll get together. So prior to that, let us know any other topics. So I think that's it. Greg, anything for you?
I have nothing to add. Thanks a lot, Brian, for chairing the meeting, and also for Bob for doing a little bit more heavy lifting than normal.
Thank you, Bob. I think we'll keep letting him do that. He does a great job.
Yeah, he's a professional moderator. Yeah.
I like that. All right. Well, I look forward to seeing you. We look forward to seeing you all around the industry and catching up with you next time. So hope you all have a good rest of the day and rest of the week.
Thank you.
Thank you all.